In this recording, we're going to learn how to solve some exponential application equations. Pretty cool stuff, because prior to this, you would have no tools available to you other than guess and check or looking at a table or a graph in order to solve for an unknown exponent. And if you ask yourself, if you're asking me, why would I ever care to solve for an unknown exponent? I would say this: money. You want to know how long it's going to take your money to reach a certain amount in an account. You're going to want to know about logs. Okay? We're going to work through one example on our half sheet companion sheet, and we'll do the rest in class. Okay, so we're going to consider this example where we have a current population in Little Pond, New York of 20,000. This is a population that's decreasing, and it has a formula represented by what's written there. We want to know to the nearest tenth of a year how many years it will take the population to reach half the present population. I encourage you to work this problem out by over on the side writing down the facts you know. So if you look at this question, you might say, well, what jumps out at me? Well, the equation does. Okay, so that's key. The equation jumps out at you. You should write that down. P is equal to A times 1.3 to the exponent negative 0.234 T. Let's know what we know. P, final population. Well, I'm not sure what that is right now. Current population. That means the same as initial, right? Initial population, current population, 20,000. Let's write that down. I also see the T. Okay. Well, it says how many years is what we're solving for. So I think that's the unknown. Therefore, this P must be in there somewhere. I just need to look more carefully. So P represents the final population. It says, when will the population reach half the present population? So half of 20,000, that's what it's implying. So you ought to be a good reader in a question like this to extract all the facts. Now we've got the facts. Plug them in. Okay, so we know that to the 1.3, sorry, base of 1.3 to the negative 0.234 T power. This is a monster, but we can figure it out, guys, because we have a calculator, right? We have some smarts, and we know about logs. All right, so you want to solve for T. First, get rid of this 20,000. It's in the way. It does not have an exponent. So we're going to divide by 20,000 to isolate the base, okay? Maybe you should make a note for yourself. So that's key. Divide by 20,000. I shouldn't say isolate the base, but to isolate the exponential expression. Okay? All right, so it turns out this is just half, or 0.5. Right, that makes sense. So it's 0.5. And that's equal to 1.3 raised to this exponent. Now it's still looking kind of nasty because we got these negatives, we got these decimal exponents. That's no big deal. Our calculator is immune to all that. It can handle negatives, it can handle decimals. I just need to put this in a form that I can put in my calculator. Fortunately, you know how to do this, right? Think back to a simple example. 4 to the x equals 10. We did this back when we first introduced logs. We said, how could we solve for x? And you wrote this as log base 4 of 10 equals x, right? 4 is the base. X is the exponent. Log is the exponent. Do the same thing over here. So that's kind of like off to the side, not in this problem. Write a log expression, or log equation in this case. The base is 1.3, so it's log base 1.3 of 0.5 equals, now the log is the exponent, so it's negative 0.234 t. Still looks kind of hard, but the left side's all numbers, right? So that's not bad. My calculator can handle that. And then I just know what to do to get t by itself. I just divide. Okay, so I can do this. Grab my calculator. I'm going to do log base 1.3 of 0.5 and then divide. So I go to my log base 1.3 of 0.5, that number, and then I'm going to divide that number by negative 0.234. And it comes out 11.29-ish years. All right. Let's pop over here, paste that information. All right. How many years? This is always a little tricky situation. What are we going to round this to? And sometimes not what you would think. So we'll say t is approximately, well, we want to go to the 10th of a year. So I think it'd be 11.3 years. Now let's test that to see if it works. We'll go back to our original equation and test it out. I'm going to raise 20,000 times 1.3. I'm going to sub in that for the years, see if it works. All right, so we're going to grab our okay, I'm going to hide that part so I can see it. All right, so clear out. We're going to go 20,000 times the parenthesis 1.3 raised to the exponent parenthesis negative 0.234 parenthesis times 11.3. Let's see if that should come out to 10,000. Well, not quite, but it's darn close. And we can accept that answer. So I'm happy with 11.3. Okay, we'll circle it. There's your answer. Thanks for watching. Now try the quiz.